Measures of center and variability. This lesson goes along with standard 6SP2. Understand that a set of data collected to answer a statistical question has a distribution which can be described by its center, spread, and overall shape. Lesson objectives. Understand that data distribution can be viewed by its center, mean, median, and mode, spread, range, and overall shape, and it can be analyzed by its distribution. Understand that the mean, median, and mode of a set of numerical data are measures of center of that set of data, and understand how the range of a set of numerical data is a measure of how data varies. We have a story problem. Students in band, chorus, and string classes collected donations for a fundraiser concert to raise money for the music program. These line plots show the results, asking 10 students from each class how much money they collected. Use the shape in each line plot to explain how the data varies. Between what numbers are most common responses for each group of students? If we look at the band, where are the most common responses? Between 10 and 20. Looking at the center line plot for the chorus, most of the numbers fall between 10 and 30. And when we look at strings, we see that it's more to the left with 40, 50, and 60. Based on the line plots, which class likely raised the most money? Explain. So I want to look at all three line plots, and I want to look at the one that has the most X's on those bigger values. Strings most likely made the most money because the data points are between 40 and 60. These points are greater than the other graphs. Based on the line plots, which class likely raised the least money? Explain. Again, I want to look at all three. We can eliminate strings because we've decided it raised the most. So we want to look and see which one has X's that fall in the smaller range of money. Therefore, band probably raised the least amount of money because most of the data points are at 10, which is one of the lowest values on the line plot. It is essential to be able to discuss the line plots, bar graphs, all kinds of data collections based on terminology that is used. So a graph is skewed left when most of the data points are clustered near the higher values. So if I look at the three line plots, strings would be skewed left because most of the cluster is found in those higher ranges, 40, 50, and 60. A graph that is skewed right when most of the data points are clustered near the lower values. So the band is skewed right because most of the X's fall within 10 and 20, which are the lower values. Symmetrical graphs have the same shape on either side of the middle point. If you look at the chorus, you have a high point, but yet it goes off to both sides in the same pattern. So it is symmetrical. A peak forms when many data points are in one value. So if we look at the band, we notice the red circle at 10 because most of the data points are sitting on 10. If we look at chorus, we also have a circle on 20 because most of the value points, the data points, fall on 20. Strings is kind of evenly distributed through a couple of numbers, so there's not a full peak. An outlier is a data point far away from the other data points. It doesn't quite fit in with the rest of the data points. We talked about the chorus is symmetrical, so that doesn't really have an outlier. However, band and strings both have outliers because you have values that are nowhere near where the majority of those X's are. So can an outlier value be part of cluster values? No. An outlier is a data point far away from the other data points. A cluster is a group of data points that crowd near each other. Now let's talk about one of the essential ways we find the center or the average of a data set. This is called the mean. It applies the concept of sharing equally among all the data points. You find the mean by adding all the values and then dividing the sum by the number of values. The number of values means you count how many values there are in all. Camila looked at the survey results for the band. Based on this data, she thinks the average amount of money raised by a band student is $10. What is the mean of the band data? Is she correct? Explain. So we need to find the mean of these numbers, which means we want to take that entire data set and we want to add it together. Our first step, add the data values. When we add those numbers together, we get 200. Now we want to divide by the sum of the number of values. We would count how many values we have in all, and we have 10. So we say 200 divided by 10, which gives us 20. So is Kamira correct? So while 10 is a mode and a measure of center, she's incorrect. 20 is the average amount of money each member brought in. I want to look at this question again because to me, Kamira had a good point. But because there are outliers, 40 and 60, could they have affected the mean? How did the outliers, 40 and 60, affect the mean? Considering the most common number was 10, it would be reasonable to assume that the mean would be around that number. But because the outliers were so large, it raised the mean by quite a bit. A sixth grade student had the following grades. He wanted to figure out his grade at this point. First, add the data values. 88 plus 91 plus 75 plus 80 plus 88 plus 80 plus 65. We get 567. Then divide by the sum of the number of values. 1, 2, 3, 4, 5, 6, 7 grades. So 567 divided by 7. That gives us 81. So his average is an 81. I hope this video helped. I hope you understood how you can look at data, how it's distributed, how its shape can help you determine answers to questions, and I hope you began understanding mean. This will be continued in my next video.